Okay, now let us talk about Bertrand equilibrium. Okay, so again, I'm going to specify the demand and the cost functions. Okay, so suppose QDP is let's take max of 12 minus p comma 0. Okay, and let's say the cost function is C1 Q1 is 2Q1. Okay, and C2Q2 is also 2Q2. Okay, so these are the cost functions. So they have the constant marginal costs. Okay, so we want to find the Bertrand-Nash equilibrium. Okay, again, the first thing that you would want to do is you want to figure out the monopoly price. Okay, so because that's kind of the best that can happen to a firm. When they're competing, if they get to choose the monopoly price and other firm is out of the industry, that's the best thing that can happen. So it's always a good idea to get an idea of what is the best that can happen to a firm by finding the monopoly quantity and the monopoly price. So notice that it's you know in this particular problem, we have the cost, we don't have zero cost, zero marginal cost, so we can't take 6. Okay, so we have to solve it. Okay, so 12 minus, and we can't use the information that we had from the previous problem. Okay, so because of these are different cost functions, so we have to solve. Okay, so if we solve for the monopoly quantity and the price, we just want to maximize this with respect to Q minus the cost. Okay, so if you do this, what are we going to get? 12Q minus Q square minus 2Q. So you're going to get 10Q minus Q square, which is 10 minus 2Q, which is Q is equal to 5. Okay, so the monopoly quantity is 5. Okay, and the monopoly price is 7. Is that clear? Is everyone getting this? Okay, so once we have this, now we can just think about finding the best response. We'll keep this in mind and we'll find the best response. Okay. So what is the problem that we are solving here? Okay, so basically we are interested in maximizing the profit of firm 1, which is a function of P1 and P2 both, and I want to maximize this with respect to P1. Okay, and so how do I solve this problem? Okay, so I want to maximize the profit of firm 1 with respect to this P1. Okay, so again, I'm going to take P2 as given. Okay, and solution to this problem will be part of the best response of firm 1 given P2. Okay, so whatever is going to solve this will belong to BR1 P2. Okay, so let's do this problem. Okay, now one thing is straightforward, given that what I've just done. Oh, by the way, you remember the Bertrand scenario, right? What are the profits in the Bertrand? So whoever is going to set the lower price gets to sell in this market. Okay, so you're going to get P1 into max of 12 minus P1 comma 0. That's a quantity, that's a price. Okay, minus the cost, which is 2 times this quantity. Okay, so let me just erase this. Okay, and write it in combined statement for this. P1 minus 2 times max of 12 minus P1 comma 0. Okay, and this is the case if P1 is less. Okay, and what if P1 is equal to P2? Well, then you split the market. So if you split the market, then you sell half of this, max of 12 minus p comma 0 divided by 2. Okay, and if p1 is greater than p2, then you sell nothing, and the cost is 0 of selling nothing, and the revenue is also 0, so the profit is 0. Is that okay? Fine. So we'll keep this in mind, and then we'll do this maximization. Now, can you tell me if P2 is higher than 7, what do you think is the best response of firm 1? 7, right? I mean, you choose the monopoly price and you'll get access to the entire market. That's the best thing that can happen. You know, the other firm is foolish enough to choose a price higher than the monopoly price, given that, you know, your best response should be 7, right? So there is a single best response in this case, which is 7. Is that clear? Okay, so for example, if P2 is 8, then your best response is 7. If P2 is 7.5, then also it is 7. Is that fine? Okay. Now, let's consider the case if P2 is less than 2. What do you think is the best response if P2 is less than 2? Notice that the per unit cost of producing is 2, right? Marginal cost is 2 and the per unit cost is also 2. So if you want to access this market, if you want to cater to this market, you have to charge a price lower than P2. So would you want to charge a price lower than P2 in this case if P2 is less than 2? Exactly, it will lead to a loss. So it's better not to produce anything if the other firm is producing at a, if other firm is deciding on a price less than 2. Yes or no? So what are your best responses given that P2 is less than 2? Anything above P2 works, right? So it's an interval from P2 to infinity, because if you charge above P2, you don't get to sell and you make 0 profit. Okay, what about if P2 is exactly equal to 2? Well, that's one of the best responses, but there are others. If you charge 2, you make 0 profit. If you charge more than 2, you again make 0 profit by selling nothing. If you charge 2, you split the market, okay, half, and you know, you make 0. If you charge more than 2, you don't split the market, you don't sell in this market, you still make 0. So basically anything from 2 to infinity, including 2, is the best response. You don't want to charge less than 2, because if you charge less than 2, then you do get the entire market, but you'll be making losses. The reason is because average cost is 2 and you are charging, price is like the average revenue, right? And you are charging less than the less than 2. Okay, so this is you know, we have, you know, like roughly wrote the best response for the entire thing, except, you know, this interval, okay, which is P2 is between 2 and 7. Okay, let's just try and write the profit, you know, the best response in this interval. Okay, now for this, what I'm going to do is I'm going to do some plotting. Okay, I'm going to plot the graph and I'll figure this out, you know, what is my best response. So whenever you are plotting the graph of the objective, you know, whatever variable you are choosing should be on the horizontal axis. So you are choosing P1, and whatever is your objective should be on the vertical axis. Okay, and this is fixed. Okay, so this is 2, this is 7. Okay, and this is P2 somewhere here. Is that okay? So P2 is also fixed, right? I mean, it's given. Okay, now you want to figure out how your profit looks in this interval. Okay, notice that if you charge more than P2, your profit is 0. So if you charge more than P2, your profit is 0. So I'm going to get a line like this, and then a dot here. Okay, a circle here. So this point is not included in the profit function. Okay, because at P1 equal to P2, when P1 is P2, the profit is given by this. Okay, so what I'm going to do is I have to figure this out, how this looks. Okay, and again, at 2, notice that the profit is 0. Okay, so at 2 also the profit is 0, because at 2, this term will be 0, so the entire thing will be 0, because P1 is less than P2. Okay, so at this term will be 0, so the entire thing will be 0. So the profit will be 0 at this point. Okay, and there will be losses if you charge less than 2. Okay, so if you see, okay, now okay, for the time being, let me ignore this P2. Okay, and let me draw the graph of this function. Okay, okay, let me draw the graph of this function. Okay, so how do I draw the graph of this function? If I just ignore P2 and just draw the graph of this function, remember, this is basically what, if you just maximize this, it is like solving a monopolist problem. Okay, if you ignore P2, it is like solving the monopolist problem, right? You're just choosing a price that maximizes the profit of the monopolist. So basically the graph will look like this. The peak will be at 7, and then it will start dropping. Yes or no? I mean, otherwise, you can just open this up. It's not a big deal, because P1 is less than 7. You can just open this up and then take the derivative. It's a simple quadratic form, which you can easily figure out, using the derivatives, how it looks. Okay, it will be like this. Is that fine? Yes or no? Now notice that this is only applicable till P2. Okay, this is only applicable till P2. So what I'm going to do is I'm going to erase this. Okay, and this point is not included. Okay, the reason is because the moment P1 is equal to P2, this term is half of this term, because we can see that this is exactly half of this term. So basically profits jumps to this point. Okay, so a question in the limits. Okay, let me ask you quickly, what is the limit as P1 approaches P2 from the right of pi 1 P1 P2? What is it? 0. What is the limit as P1 approaches P2 from the left of pi 1 P1 P2? It is this value. So how do you get this value? You simply put P2 here. So you're going to get P2 minus 2 into max of 12 minus P2 comma 0. Is that okay? It is P2 minus 2 into max of 12 minus P2 comma 0. Okay, and what is the value of this at P2? So P1 equal to P2. So basically pi 1 P2 P2. What is pi 1 P2 P2? Pi 1 P2 P2 is this value, right? It is exactly half of this. Is that clear? Okay, let's come back to this problem. Now, can you tell me where is the profit maximum? Where is the profit maximum? At what value of P1 the profit is maximum? What do you mean by P2 minus? You have to tell me some value of P1, right? Is there some value of P1 where the profit is maximum? Basically, this P1 doesn't exist. There is no such P1 because the closer you get to P2, the higher the profit. It's an empty set. The solution doesn't exist because the closer you get to P2, the higher the profit. So there is no solution to this problem. So you cannot say just less than P2, okay? Because you have to give me a value where it is maximum. There is no such point, okay? Because as you get closer to P2, it increases, and the moment it hits P2, it becomes exactly half of it. So clearly, you are climbing here, but there is no peak here. Okay, there is no peak. You keep climbing, and then suddenly you jump. There is no point where it's like an open set problem. Okay, so well, that's fine. We have this. Now we can simply plot the two best responses and figure out the Nash equilibrium. Well, you don't have to plot it all the time. I mean, you can also look at it and say, okay, so let me just tell you how to look at it and say as well. Okay, like for example, if you see when P2 is greater than 7, then the best response of firm 1 is 7. But if firm 1 produces 7, then firm 2's best response is, well, it's a null set. So that's not a Nash equilibrium. Okay. So what that means is that, by symmetry, no firm in a Nash equilibrium will charge more than 7. Okay. So let's maybe look at a situation where one of the firm charges between 2 and 7. Again, if any firm charges between 2 and 7, there is no best response. So clearly that can never be an Nash equilibrium. Okay, because you have to have two best responses. So P1 should be a best response to P2, and P2 should be a best response to P1. Okay, so that leaves us with these two possibilities. One is P2 is 2 and the other is P2 is less than 2. So let's evaluate this one first. So if P2 is less than 2, the other firm would like to charge higher than P2. Okay, and then in response, this firm would want to charge higher than P1 because it's kind of symmetric situation. So you wouldn't want to sell at a price lower than 2 because you can always charge 2 and make 0. Okay, so this is also ruled out. Okay, so the only possibility is this one. Okay, if P2 is 2, you can see that 2 is the best response. Okay, I agree there are other best responses as well, but then if you look at the other responses, they'll fall into this category or that category, and then there'll be a problem. Okay, so if P2 is 2, 2 is the best response, and similarly P1 is 2, 2 is the best response by symmetry, and therefore 2, 2 is a Nash equilibrium. Okay, so that's one way. If you just if you can just read this both ways, for player 1 as well as for player 2, you can just do it like that. Okay, otherwise obviously you can plot. Okay, which is again not that difficult. So these are, so I'm going to draw 45-degree line because that's going to help. The reason is because if you see, this is P2. When P2 is less than 2, it is P2 to infinity. When P2 is 2, again it is P2 to infinity. Okay, so so if I draw the 45-degree line, that will help. Let me draw the 45-degree line like this. Okay, so this is P2 equal to P1 line. Okay, 45-degree line. Okay. Okay, now let me consider these cases. Okay, and for each case, I'm going to plot the best response of form 1. So 2, 7. Okay, so these are the two numbers that I have to take into account, 2 and 7. Okay. So if P2 is greater than 7, 7 is the best response. So if P2 is greater than 7, okay, then 7 is the best response. So what is 7? Well, let's just come to 45-degree line. This is 7. okay, and this is 2. Okay, so when P2 is greater than 7, 7 is the best response. So I'm going to plot a vertical line like this. Okay, so whenever P2 is greater than 7, 7 is the best response. And I'm not going to fill this point because at this point, there is no best response. Okay, so this point on the green line is not included. Okay, now when P2 is between 2 and 7, there is no best response, so I don't have to fill anything. I don't have to draw anything. Okay, it's an empty set. If P2 is equal to 2, okay, then anything from 2 to infinity is the best response. So I'm going to plot a line like this, because anything, so P1 can go from 2 to infinity. Okay, when P2 is greater than 7, P1 is 7. When P2 is 2, then P1 is anything from 2 to infinity, and 2 is included. So I'm going to put this point in the graph. Is that okay? And when P2 is less than 2, then anything above P2 will work, but P2 is not included. Okay, so what that means is anything to the right of this 45-degree line, but this green line is not included. So I'm not going to put a red color on this green line because this green line is not included, but I'm going to shade the remaining. Okay, now let me plot similarly, the best response of firm 2. Well, it's a symmetric situation, so I don't have to do the calculations again. I'm going to simply plot something which is just symmetric to this red one. Okay. And then this red I'm going to just fill this as well, okay, with the gray color. So notice that this is a point where the intersection happens, and this is the only point where the intersection happens. And that is exactly what we just found, right? I mean, just by looking at the best response, we found that 2, 2 is the Nash equilibrium, and that is exactly what we are getting here, using our intersection thing. Okay, so this is the Nash equilibrium. Okay, so both firms will charge their marginal cost. Okay, I mean, in this particular problem, okay, don't generalize it. Okay, in this particular problem, it turns out that the Nash equilibrium is that P1 P2 is equal to 2 2. Okay, so that's the Nash equilibrium, and both firms make zero profit in this. Okay, is this fine?